Welcome to Math Mini Lessons. We have a really spicy problem for today that connects tons of different skills, so this video is going to feel a little longer. In lesson 43, we're going to model linear functions. That means we're going to be given a word problem, and today's word problem is a 6-point Regents problem. So it has lots of different components. So we have to make sure that we accurately understand the situation, and we can create a table of values to represent that situation. That we can express the problem as a function if asked. The problem we're going to model is just an equation, however, not a function. And that we're annotating the problem and the graph to analyze the question and get specific information. So again, it's going to be meaty. So if you need to chunk this out into smaller sections, we can. But we're going to jump right in. Zeke and his 6 friends are going to a baseball game. Their combined money totals $28.50. At the game, hot dogs cost $1.25 each, hamburgers $2.50 each, and sodas are 50 cents each. Each person buys 1 soda. So, okay, since we know that there are 7 boys, 7 times 50 cents is equal to $3.50 just on soda. And they spend all $28.50 on food and soda. So our first question is we need to write an equation to determine the number of hot dogs, X, and hamburgers, Y, Zeke and his friends can buy. So we know that they're going to spend all $28.50, and I want to figure out how many hot dogs and hamburgers, but I need to deal with the soda part. So I'm going to take the $28.50 and subtract the $3.50. And I have $25 left. Let's write out this equation. We know that they're going to spend $1.25 on hot dogs, so $1.25x plus $2.50y equals $25 because they're going to spend every penny. This is not an inequality. They're going to spend all of it. Now, this is written in standard form, and that's okay. We're going to use that. We're not going to rewrite this into y-intercept form. You can, but it's not going to be necessary, and I'm going to show you why. So I want to graph this equation, and all I need are 2 points to graph this equation. So the 2 points I'm going to use are going to be my intercepts, my x-intercept and my y-intercept. So what I'm going to do, so you can see it here, I'm going to solve this equation for when x is 0 and when y is 0, because that will give me 2 points so that I can graph this equation. So this is going to be my hot dogs, and over here I'm going to have hamburgers. Okay, so let's take a look. I'm going to use my original question, and let's try when x is equal to 0. So I'll do that part first. So this obviously cancels out completely, because anything times 0 is 0, and you see why I wanted to use intercepts. So 250y is equal to 25, so I'm going to divide by 250, and I get y is equal to 10. So my first point is 0, 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Graph the first one, and then I'm going to do the same thing for my y-intercept. So I know this cancels out, and I get $1.25x is equal to 25. Divide both sides by $1.25, and you get x is equal to 20. So my next point is 20, 0. And boom, here we have it. I have 0, 10 as a point, and I have 20, 0 as a point. I'm going to just connect the lines, connect the 2 points, and I have my equation and I have my graph. So all I needed. So hit pause and jot this down into your notes. Determine how many different combinations, including those combinations containing 0 of hot dogs and hamburgers Zeke and his friends can buy, spending all $28.50. Explain your answer. So I'm going to look for all those combinations on my graph, and because we're talking about buying hot dogs and hamburgers, I am going to look for whole number combinations. I can't go and say, can I have 3/4 of a hamburger? I could only ask for whole numbers. So here would be my first one on top. And that would be when I have 0 hot dogs and 10 hamburgers. So that's 1. Here would be my next one when I have 2 hot dogs and 9 hamburgers. Here's 4 hot dogs and 8 hamburgers. And you're probably noticing a pattern develop. So you're probably noticing that the number of hot dogs is increasing by 2 each time. I know the next one will be 8. And my hot dogs are increasing by 2. My hamburgers are decreasing by 1. Okay, so all I'm going to do is list all of these combinations. This one is 0, 0. And seeing that, I can now answer how many different combinations are there. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 combinations. And I now would just list all 11 of those combinations. And that's it. That's the only thing left to do in this problem. So you can hit pause and jot this down into your notes while I finish the last of the combinations. Here we go. I determined there are 11 combinations of hot dogs and hamburgers they can buy. From $28.50, $3.50 was spent on soda. So I want to explain that so we know where the 25 came from and so no one is left guessing. Clearly, the person grading knows where it came from. They want to make sure that you also understand that context. Using the equation 125x plus 250y equals 25, I found 11 combinations for food purchases. Since we can't buy fractions of food, the combos represent whole numbers of hot dogs and hamburgers they can buy with, I'm going to add this, with $25. And that's it for this part. I told you it was a meaty problem, lots of different parts, but we did a fantastic job. We started out, and this was, I believe, a 6-point problem. We started with taking a word problem, breaking it down to write an equation, using that equation to get 2 points that we can graph, and we got it. Then once I had the equation, just to make sure there was no human error, I did graph it. And I used my y equals mx plus b form to graph it, and I just wanted to make sure all my points were right, but that helped me make all the different combinations, and then I answered it in words. So that's it for today. That's the practice you're going to get. You're going to get a word problem, and you're going to have to create a table of values from the situation. You can either substitute to get those values, or once you have an equation, you could use your tools to graph the equation or create a table of those values. Depending on the problem, see if they want you to write your equation as a function or an equation, and just make sure you're annotating your graphs to make sure you're getting the right information to answer the question. That's it for today. I'll see you in the next one. Be well.